Hi, I am Julia, and I'll be telling you about buffers. Buffers are one of my favorite things, and the math is pretty simple. First off, there's some things you need to know. Conjugate acids and bases. It will be very important to be able to identify what acids and bases are conjugates. Next, you need to remember simple acid and bases, and the acid and base dissociation constant, otherwise known as the Ka and Kb. The Ka will be used in the actual equation to calculate the pH of a buffer. Finally, you need to know the equation for pH, which you should already know from pre-AP Chem. Next off is a very mysterious question of what is a buffer. First off, what makes a buffer is an acid and its conjugate base. It's very important that they're both weak, so the buffer can release hydrogen ions and accept them at will. And once again, these have to be weak and specifically not strong, so they can both be in solution at the same time, because otherwise the strong components would dissociate completely, leaving no solution. Next, what does it do? It counters changes in pH. If you add a strong acid or a base, and the buffer causes the pH changeless by releasing and accepting hydrogen ions. Now, how are buffers awesome? They cause you to not die. Seems pretty good to me. If the pH of blood changes 0.4 in either direction from 7.4, you die in minutes. So 0.01 moles of a strong acid is added to 1 liter of water. The pH changes from 7 to 2. The same amount of strong acid is added to 1 liter of blood, and the pH changes from 7.4 to 7.3. That's because of the magic of buffers. Next is understanding what the equation tells us. The most basic component in the equation is the H plus concentration. It is simply what you need to calculate the pH. Ka is the acid dissociation constant. If you are given a base and its conjugate salt, you will most likely be given the Kb. You will need to convert this Kb to Ka using Kw, the water dissociation constant, which is 1.0 times 10 to the negative 14th. If you don't know how to convert that, I will be showing you that later, so don't worry. The acid is Ha, which would be the concentration of the weak acid added, or the conjugate salt of a weak base. The base is A-. This will be the original concentration of a weak base, or a weak acid's conjugate salt. So these two things together make up the acid-base ratio. And that is the equation. It is one of the easier equations, and the best thing is the only equation for the entire buffers unit. Okay, so a buffered solution contains 0.250 molarity of NH3 with a Kb of 1.8 times 10 to the negative fifth and 0.4 molar NH4Cl. And I want you to calculate the pH of the solution. The first thing I want you to notice is the Kb. And note that you will have to calculate the Ka. The next thing you should notice is the acid and base. The main compound being added is NH3, and that is a base. And NH4 from the NH4Cl is the conjugate acid. The NH4 concentration will go on the top because it is the acid, and NH3 will go on the bottom because it is the base. Now, there are 3 basic steps to solving, and there will only be 2 if the Ka is given. And the first step is to solve for the Ka. So, the Kv is equal to 1.8 times 10 to the negative fifth, and you have the Kw, which is equal to 1.0 times 10 to the negative 14th. So Ka times Kb equals Kw, and then using that equation, realize you need to divide Kw by the Kb. And then substitute in, you get 5.56 times 10 to the negative 10th. Now you can use this in the buffers equation. So, what is the H plus concentration? The acid concentration is 0.4 and the base concentration is 0.25. And finally, you have the Ka, which was calculated in the last step. So now you have the equation. Plug everything in, and now we're going to divide 0.4 by 0.25 and get 5.56 times 10 to the negative 10th multiplied by 1.6. And the H plus concentration is found to be 8.89 times 10 to the negative 10th. And now, since it wants the pH, the final thing to do is solve for the pH. And since you have the H plus concentration plugged into the pH equation, you get 9.051 as the pH. For the next problem, I just want you to look at the problem and be able to realize that you have to recalculate the concentration or calculate the moles. It is better to calculate the moles when we get to invading acids and bases, which is the next topic. When buffers are attacked, there would be no real reason for buffers if they weren't invaded by other acids and bases. Since a buffer has an acid and a base component, it can come to the addition of acids and bases, specifically strong ones. The base part of the buffer counters strong acids. And you add the acid to the top since it creates more weak acid due to the neutralization of the weak base. More weak acid gets produced since the weak base is combining with H plus ions, turning into the weak acid. And the neutralization of the weak base is why the acid is subtracted from the bottom. The acid part of the buffer counters strong bases. Subtract the base from the top since the acid neutralizes it. Add the base to the bottom since it creates more weak base. This is because the weak acid breaks down to produce H plus ions in the weak base. The weak acid wants to release those H plus ions so that they react to neutralize the H ions released by the strong base. And now to a practice problem. This is the type of problem where you'd want to calculate the moles. But you don't have to do it for this specific problem since no volumes are given. So first, we are going to calculate the H plus concentration. Since HCl is a strong acid, 0.1 gets added to the top and subtracted from the bottom. And you get 0.85 divided by 0.15, which is 5.7 when rounded according to sig figs. And then you multiply that by 1.4 times 10 to the negative 4th. And you get H plus concentration of 7.9 times 10 to the negative 4th. Then the next step is calculating the pH. Using the pH equation and plug in the H plus concentration. And you get a concentration and you get a pH of 3.1. And yes, I know I left off the 0. I just forgot to put it in there. It needs to be in there for sig fig reasons, otherwise you could leave that off. Next, we're going to make a buffer. This can be difficult, so you really need to pay attention. First off, you need to remember the buffer's equation. I told you it was used for everything. Next, we'll analyze the Ka. Take the pKa of the Ka. Now make sure it's close to the pH you want. Now let's analyze the acid-base ratio. You want it to be 1, and this makes the Ka equal to the H plus concentration. which is also why we want to take the pKa of the Ka, so that we can actually see like what the pH would be, and not just having to look at the H plus concentration related to Ka, because that is like additional math and really hard thinking to figure out those, and it's easier just to take the pKa, since normally it will tell you what the pH they want the buffer to be. And another reason that you want the ratio to be 1 is it helps minimize changes in pH. An unbalanced ratio will allow the pH to change faster than a balanced ratio of 1. And that's it. Use the 5 buffers. At least I hope you did. And once again, this is Julia. Bye.